Hello friends, and welcome. Every single day, the world creates roughly 2.5 million terabytes of data. That is streams, swipes, purchases, sensor readings, and search queries, all flying around non-stop. Your favorite apps are generating and reading that data constantly. When you place an order on Amazon, search on Google, or queue up something on Netflix, data is being written and read in milliseconds. So here's the question that drives this whole video. Where does all of that data actually live? It does not just float around. Something has to catch it, organize it, and hand it back on demand. That something is a database system. In this video, we are going to pull the whole picture apart, from the basics all the way to how databases now power AI agents in 2026. Let's get into it. Alright, before we look at any specific database product, let us understand what a database system actually is. At its core, a database system has 3 tiers. The top tier is your application layer, the code running in your app. The middle tier is the DBMS, which stands for Database Management System. This is the engine. It handles query parsing, optimization, transactions, and access control. The bottom tier is the storage layer, the actual disk, SSD, or NVMe SSD drive where bytes physically live. When your app writes data, a request flows down through the DBMS to storage. When it reads, the result travels back up. The DBMS is the piece that makes a raw disk useful. It enforces rules, guarantees consistency, and translates high-level queries into low-level read and write operations. Popular examples include MySQL, Postgres, and Oracle, all of which sit in that middle tier and do the heavy lifting. Next, let us see how data is actually organized inside one of these systems. Now look at this. A relational database organizes data into tables, and each table is like a spreadsheet with a fixed set of columns. Our e-commerce site has a users table with a user_ID, name and email, and an orders table with an order_ID, a user_ID, and an item. That user_ID column is the primary key in users and a foreign key in orders, and that relationship is what lets the two tables talk to each other. To ask a question across both tables, we use SQL, which stands for Structured Query Language. The query on screen joins users to orders on that shared user_ID, then filters, where user_ID is equal to 1, giving us Alice's order. You get select to read, insert to write, and join to link tables. SQL has been the standard language for this since the 1970s, and it still runs most of the world's financial and business data today. That said, relational models have limits, and that is what pushed the industry to build something different. Here is the interesting part. Relational databases are brilliant at structured data with clear relationships, but around the mid-2000s, companies like Amazon and Google were handling hundreds of millions of users and billions of events per day. A single relational table cannot scale infinitely across thousands of servers without serious complexity. That gap drove the NoSQL movement. NoSQL does not mean NoSQL at all. It means not only SQL, and it covers several different storage models. A document store like MongoDB keeps data as flexible JSON-like documents, so you can iterate on your schema without rewriting tables. A key value store like Redis maps a key directly to a value and responds in microseconds, which makes it perfect for caching sessions and leaderboards. A graph database like Neo4j stores nodes and edges and excels at finding relationships in connected data, like social networks or fraud detection. Each model trades the rigid structure of tables for speed and flexibility in one specific dimension. And now, a new dimension is emerging, one that is all about AI. Let me show you where databases and AI collide, because in 2026, this is the most active frontier in the field. When an AI agent needs to answer a question using your company's private data, it cannot search by keyword. Instead, it converts text into a high-dimensional vector, a list of numbers that captures meaning, and then asks the database, which stored vectors are most similar to this one? That is called vector search. At Google Cloud Next 26, held in April 2026, Google announced that AlloyDB now scales to 10 billion vectors using their SCANN index, with queries up to 6 times faster than standard Postgres. At the same event, Google shipped fully managed Model Context Protocol servers for AlloyDB, Bigtable, Firestore, and Spanner, letting AI agents talk directly to live databases without custom connector code. Meanwhile, Postgres, with roots at UC Berkeley over 40 years ago, stays relevant through the PG vector extension, which adds vector search to the same database already running your relational tables. One engine, 2 workloads. That flexibility shapes the final decision we need to talk about. Alright, let's bring it all together. You now have a mental model for the whole database spectrum. Relational databases like Postgres and MySQL are the right call when your data is structured, when you need reliable transactions, and when your team already speaks SQL. NoSQL databases like MongoDB, Redis, and Neo4j shine when you need schema flexibility, massive horizontal scale, or graph traversal. And vector databases, including PG Vector right inside Postgres or dedicated services like AlloyDB and Pinecone, are the foundation for any AI feature that needs to retrieve context by meaning, not by exact match. The industry in 2026 is moving fast toward multi-model platforms that collapse all three into a single engine, so you stop choosing between capabilities and start choosing the one tool that covers your whole workload. The core skill is not memorizing product names. It is understanding what each model optimizes for and matching that to your problem. Thanks for watching, and we will see you in the next one.